In this lesson, you will learn to apply the definitions of complementary and supplementary angles, as well as state and use the theorem about vertical angles. So let's begin with complementary and supplementary angles. Complementary angles are, by definition, two angles whose sum is 90 degrees. So for example, here we see a triangle, and by the way, this is a right triangle. We know that because of this little box in the corner. So this means 90 degrees. Notice that measure of angle BAC right there plus measure of angle BCA right there, those would add up to be 90 degrees. So we can say that angle BAC and ACB are complementary. Here's another example where we see that if we were to add together angle DEG and then GEF, the 30 degrees plus 60 degrees, then we would have 90 degrees total. So those two angles we would say are complementary. A type of question that you could be asked would be, find the measure of the complement of angle A. So the complement of angle A is the angle that would be complementary to that angle A. So what angle added to A would give you 90 degrees? So if the measure of angle A is 43 degrees, the question is, what is the measure of the complement? What angle would add up to give you 90? Well, if I take 90 minus 43, that's going to give me 47 degrees. So 47 degrees would be the measure of the complement of angle A. Now for supplementary angles, these are angles that add up to be 180 degrees. So for example, here we have two angles, angle ABC and GEF, that add up to be 180. So therefore, those two angles would be supplementary. Another example would be right here, where we see that HJL, the 150 degree angle, and LJK, the 30 degree angle, would add up to 180. So therefore, those two would be supplementary. By the way, a little side note, supplementary angles require two angles to add up to 180. That is different than a straight angle. A straight angle is one angle that is 180 degrees. So this is a straight angle. This would not be supplementary. So the one here in red would not be supplementary because, by definition, we need two angles whose sum is 180. Same thing for complementary angles. A right angle, just like this, would not be complementary because complementary angles also require two angles adding up to 90 degrees. So take note of that little nuance in the definitions. A type of question that could be asked in this scenario would be to find the measure of the supplement of angle A. So the supplement would be the angle that adds up with angle A to give you 180 degrees. So for example, if measure of angle A is 43 degrees, the supplement to this would be something that adds to 43 to give you 180. So if I subtract 180 by 43, I would get the supplement, which would be 137 degrees. Another type of angle to discuss is what we call vertical angles. Vertical angles are, by definition, two angles that are across from each other. So you see like angle 1 and angle 2, the ones that are yellow, those would be vertical angles. Angle 3 and angle 4 would also be vertical angles because they're across from each other. Now a little more specific definition, not only are they across from each other, but they need to be such that we have two angles where the sides of one angle are opposite rays to the sides of the other angle. So for example, if you look at angle 3, right here, this angle, if you were to extend both of those segments, or those rays, extend this one this way, and then extend this one this way, notice that we have opposite rays. Okay, so these opposite rays form this other angle which would be the vertical angle. Now this is important because if you're given a picture like this, it's not quite as obvious which one is the vertical angle. If we just say it's across from a certain angle, well, it's not quite enough information to determine because we have a couple that look like they could be across from another angle. So if I said find the vertical angle to angle 1, so looking right here at angle 1, so if you were to draw this out, and this is actually a helpful technique to figure out the vertical angle, to make sure you don't have the wrong one. If you were to extend this ray right there, and extend this ray right here, notice angle 4 is what we've just created. So angle 4 would be the vertical angle to angle 1. If you look at angle 5, which would be right here, and were to draw out the rays that make up angle 5, and then let's extend this ray and extend this ray. Notice the vertical angle would be angle 2. This is the angle that was created by extending the rays. So angle 2 would be the vertical angle to angle 5. And now looking at angle 3, the vertical angle to angle 3, which is right here, would be found by extending each of the rays, which would be right there, and then right here. So notice the vertical angle to angle 3 would be the one across from it, which would be angle 6. So angle 6 is the vertical angle to angle 3. Now a fact with vertical angles is that vertical angles are going to be congruent. Now a fact about vertical angles is that the vertical angles will always be the same measure. So for example, if angle 3 were 100 degrees, then angle 6, the vertical angle, would also be 100 degrees. Now before we can actually conclude that, we need to prove that statement to be true first. So I'm going to walk you through a proof that vertical angles are indeed congruent. And with this proof, I would recommend following along as best you can and even try to stay ahead of me with the proof, because at some point in the near future, you will be expected to know how to do this by yourself. So it's helpful just to watch different proofs so that you can kind of get the feel of how to do them by yourself. So with this proof, we are given that angle 1 and 2 are vertical angles. And the goal is to prove that they are congruent, or we could say the measures are equal. So the first thing you want to do is set up your statements and reasons column. And the first statement will always be your given statement. So the first statement is that angle 1 and angle 2 are vertical angles. And the reason is because it is given information. So from here, I need to somehow link together angle 1 and angle 2. Well, if I use angle 3, I can actually link them together, because if I add up angle 1 along with angle 3, notice how when I put them together, I get the entire line. And a line, by definition, has 180 degrees. So we know that if we were to add a measure of angle 1 plus a measure of angle 3, that's going to equal 180 degrees. And same thing with angle 2 and angle 3. If I add angle 2 and angle 3 together, notice that's going to create this entire line right here, which is also 180 degrees. So now we have two equations where both of them are equal to 180. By the way, we also need a reason for this. Why can we add these together to get 180 degrees? Well, that would be your angle addition postulate, which says that we can add two small angles together to equal the measure of the bigger angle. In this case, we happen to know the measure of the bigger angle of this straight line to be 180 degrees. So now from here, notice the two equations are equal to 180. So what I can do is, in place of the 180, right there, I can put in measure of angle 2 plus measure of angle 3, because those are the same thing. So what I can have is, instead of measure of angle 1 plus measure of angle 3 equals 180, I can say measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. And all I did was substitute it. So that would be my reason for step 3, is because of the substitution property. Now notice from here, all I need to do is get rid of this measure of angle 3. And then I'd have measure of angle 1 equaling measure of angle 2. So I want to just subtract them from both sides. But before I can subtract them from both sides, what I need to do is, because they're not a number that I'm subtracting, I need to first prove, or show in the proof, that measure of angle 3 is indeed equal to itself before I subtract. So we have to say measure of angle 3 equals a measure of angle 3 by the reflexive property. And then from there, I can subtract that measure of angle 3 from both sides, which would leave me with simply measure of angle 1 equaling measure of angle 2, which is the same thing as saying that angle 1 is congruent to angle 2. And the reason for that is because I'm subtracting the same thing from both sides, which would be the subtraction property. So we're done. We've proven that vertical angles will always be congruent, or we can say that the measures will always be the same. And that brings us to the end of today's lesson. So we will see you next time.